Well, I will start with a cliché stating that all control forces in a vehicle are developed at the four contact patches of the tires, and these are quite small, so quite insignificant at first sight. As vehicle dynamics engineers, we're interested in predicting tire forces, these control forces on a vehicle, and we do this using mathematical models of tires. And these models we run on big computers alongside vehicle mathematical models. First of all, many people will have experienced such mathematical models of tires running on computer games, for example, that you might play in your free time. The models we develop here are quite more complex and of much higher fidelity. What we try to do is replicate the exact forces that happen at the tire contact patches. And this is really important for safety and performance prediction of modern vehicles. A very important part of our work is validating our mathematical models so that we know that they are true, they show us the real thing. And to do this we use complex test rigs with which we can position the tire at different steer angles, we can apply different amounts of braking, and we can record the produced forces at the contact patch. And with all this knowledge we can validate our mathematical models, we can compare the results with the models we develop and run on our computers. Looking at the four contact patches more closely, we find that contact is even smaller than we might initially anticipate. So back in 2001, a researcher called Bo Persson gave us a theory of rubber contact and friction. And this predicts that within these small contact patches, contact happens in smaller, sparse regions. And then if we magnify into these small, sparse regions, we find even smaller contact regions, and so on and so forth. Our current work involves predicting the temperature rise at these sparsely distributed little contact areas within the contact patch of a tire. And this is really important because rubber friction depends a lot on temperature, and therefore the tire forces depend on temperature as well. You can see the predicted increase in temperature along a small contact area in a span of a few milliseconds. And it is very surprising to realize that the temperature can increase as much as 100 degrees centigrade in a fraction of a second. One of the elements that hasn't been investigated thoroughly so far is conduction between the tire and the road. So we currently work on understanding how much heat is conducted from the tire to the road, and we're also working to understand the effect of other factors in rubber friction and therefore tire force production. The industry is really interested in this topic, so we are currently working with automotive manufacturers, including Formula One teams, and I would say that the future of tire modeling seems very exciting. My name is Georgios Mavros. I'm a senior lecturer in vehicle dynamics at the Department of Aeronautical and Automotive Engineering in Loughborough University. And my main focus is vehicle dynamics and specifically tire dynamics.